Okay, good morning. Um, I'll just give a couple of minutes for you guys to settle down, and then we can probably get on with the next session. Okay, so my name is Ram Venkatramani. So I'm part of the Telco Nfe business unit within VMware, focused more on delivering virtualization infrastructure solutions, particularly to the telco market. So we have had, in this particular Openstack summit, as well as in the previous summits, we have had a lot of dedicated tracks for different industry areas, and one of them has been Telco Nfe. And as has been the case even in this summit, we have had many topics, many speakers coming up on the stage and talking about what are all the key challenges and key use cases that the telcos are seeing in their particular market, and how Openstack can essentially deliver the requirements that they have for their specific needs, right? So in this particular topic, I'm going to be stressing a little bit more on a specific aspect of that particular broader question, and that is how can telcos build and manage a highly scalable and highly available virtual infrastructure, right? So that's really going to be my focus of the topic. I'm not going to get specifically into what are all the various use cases in the telcos and things like that, but I'm going to be focusing more on how to build and operate and manage a carrier-grade cloud delivering network solutions for telcos. Now, before I actually get started with the presentation, I would like to understand, are there any telco individuals in the crowd, in the audience? Anybody from the telcos? Good. Okay, we have a couple of them. Cool, thank you. So some of the challenges that I'm going to be outlining, I'm pretty positive that you would probably resonate well with it, and you will acknowledge that, okay, this is something that you are thinking as well. So with no further ado, let's just jump into it. The last couple of years, right, so we have seen an explosion in different access capabilities, right? There is a huge transformation that is happening in the industry, right? On one front, we are seeing a rapid explosion in a connected ecosystem. Connection not only in terms of devices like your wearables or sensors and things like that, but we are also hearing a lot about connected car kind of scenarios, or autonomous driving, and then we are also looking at smart meters and smart cities as well. Like if you had been to MWC last year, or rather earlier this year, you would have seen many of the telcos demonstrating smart city use cases, right? So the world is completely getting connected. It's undergoing a major transformation in terms of network connectivity standpoint. Now, if you club that with what is really happening on the business front, right, you see new kind of business models emerging, right? Now, the telcos are also looking at this as an opportunity for them to grow their revenues, right? In the past, you see them primarily providing connectivity services, but now this digital transformation is giving them a unique opportunity to expand their revenue generating capabilities, and they want to leverage this opportunity. Now, if you map this with what is really happening from a network and cloud standpoint, new things are also coming up there as well. Like you have network function virtualization, which is no longer new anymore, but that's something that is really kicking up steam and getting mainstream deployments in the past couple of years. And we are now talking about self-optimizing networks. This has been everybody's panacea maybe a decade ago, but now it's becoming more of a reality, right? With closed-loop automation systems and things like that. So if you club this and look at it from what is exactly happening within the telco service delivery standpoint, now you will identify 4 different ways in which carriers are trying to deliver the service to their customers, right? When I say 4 different ways, I'm essentially talking about 4 different types of clouds, right? You have the IT cloud, which is primarily dedicated in delivering their own internal IT applications. And then we have the operator services cloud, which has been designed to host the network services per se, or in other words, what we call in the telco industry as virtual network functions, right? And then the third one is public cloud. Now this is not attained a huge adoption, but it is nevertheless being spoken about in the telcos, and they are considering adopting it in some pockets for specific use cases. And the last one is managed cloud service. I mean, this is where the telcos want to run a cloud of their own and offer that as a service to their enterprise customers. Classic use case is a SD-WAN kind of a use case, right? So where they want to run CPE kind of services for specific enterprises, but running it in their own cloud. So when you see this kind of transformation happening in their clouds or in the network area, and now if you club that with the innovation that the 5G technology is likely to bring, what you are essentially going to see is an explosion in terms of use cases and applications, right? I mean, there is a multitude of capabilities that this is going to unleash, and as a result, there is going to be a plethora of use cases now the telcos will have to cater to. And I mean, believe me, the point is not about enabling the use cases. The important element here is being able to provide guaranteed connectivity at the SLAs that the telcos are signed up to deliver to their customers, right? In some cases, people have to deliver 5 nines reliability or 6 nines reliability, right? If you're, for example, in one of the earlier talks, AT&T was talking about delivering connectivity services for, I think it was an ambulance service in New York City, right? Now, if you think about that particular use case, a healthcare kind of a use case, availability and SLA is absolutely important, right? You cannot have your network go down even a bit because somebody's life is on the track, right? So with this kind of a background, now if you try to now look at, okay, what do I need to do? What does a telco need to do in order to deliver these use cases across all these 4 disparate clouds? Then certain important elements crop up, right? Oh, sorry. So there are certain important elements that they would have to cater to, right? So to begin with, you need to have a unified, common operations management plane, right? Without that, it becomes extremely siloed approach, right? So you want to have a common infrastructure management plane or an operations management plane that goes all the way from building and managing a cloud to all the way to defining policies and also instituting governance models. Now, governance, I mean, it may not necessarily be a key thing for enterprises, but for the telcos, it's very, very important because it's primarily in many countries, it's a regulated industry. Telcos are operating in a regulated environment. So governance is extremely key. So you don't want to have governance models that is specific to individual clouds. You want to have that be common and implemented across your entire virtual infrastructure. So how do we do this, right? So in order for us to deliver this, there are 2 key aspects that telcos have to implement. One is a multi-tenanted cloud infrastructure management. Now, I want to stress this a little bit, which is the multi-tenancy aspect, right? Multi-tenancy here does not necessarily mean just supporting different tenants. I mean, being able to onboard different enterprises in my network. It means a lot more than just that, right? When you onboard enterprises into your network, you have to give 2 key things. One is resource guarantees, and the other one is also a resource isolation, right? So when you deliver, and basically when you sign up an enterprise for a particular service, and when they say, okay, initially I want to be consuming, let's say, 5 gigabits per second of throughput, that's good. But suddenly if they say, okay, I want to grow my service to 100 gigabits, then you need to be able to deliver that capacity. You should be able to reserve that capacity beforehand and deliver it as and when the need arises. So that's one aspect of multi-tenancy when you're talking about it from an enterprise standpoint or a customer standpoint. But even within the telcos, this is an interesting element, because if you look at various telco organizations, the telco organizations internally, they are structured as independent, smaller sub-organizations, right? So you will have a EPC organization, which is primarily focused on delivering EPC services to their customers. And there could be another GI LAN services organization, which is essentially targeted and designed to deliver GI LAN services like DPI services or things like that, right? So now each of these individual sub-organizations, they have their own planning function, product realization function, as well as operations function, right? So now in that kind of a model, you need to build some level of strict fences between these sub-organizations as well. So you don't want typically a EPC workload interfering with an IMS workload, because the support guy for the EPC or the operations guy for the EPC workload, he will have access only to the EPC farm. He won't have access, he should not have access to the IMS farm because he doesn't know anything about it. But in the physical world, it was extremely easy to implement, right? Because EPCs had their own appliances, the GI LAN services had their own appliances, so it was extremely easy in instituting this level of multi-tenancy in the physical plane. But once you move to the virtual plane, it's all muddied around, right? So you can have a EPC instance running on the same host as another IMS instances running, for example. But then how do you build this fence between the two? So that's where the multi-tenancy comes into the picture. So you not only need to guarantee resources, but you also need to provide isolation between these tenants. So that way, you don't have any noisy neighbor kind of a situation. For example, you shouldn't have an EPC application consuming all your network bandwidth in your host such that your voice call is unable to go through, right? You shouldn't get into that kind of situation. So that resource isolation is extremely key. So that's the multi-tenancy aspect. The second one is operations management, right? Once you have defined this multi-tenancy model, now you need to how do you ensure that the individual organizations or the individual groups can now manage their own portion of the network, right? Without interfering again with the other elements. So these are two key things that we need to be thinking about as we design and implement a telco network. Now let's double click a little bit into the operational aspects specifically, right? Again, in the physical plane, it was extremely simple. You were able to identify every single individual application because they were instituted or they were basically realized as an individual application or individual appliance. So you can directly connect to that appliance and gather metrics or gather statistics or health and things like that. But in a virtual world, it's extremely dynamic. Things are constantly moving, right? Yes, you are instantiating a virtual EPC application, but it's not staying in a single location. It's constantly moving around in your virtual environment, right? So what that means is, now let's take a very simple example, topology, right? Network topology. If in a physical world, I mean, many IT organizations in the telcos, you used to have a network topology laid out on paper, right? So you could see, okay, this is how my EPC is connected to my IMS, to my GA LAN service. It's very simple. In the virtual world, the topology is constantly changing. It's constantly dynamic. So now when you operate such a network, how do you figure out, okay, what's my current topology? So you need a mechanism that can automatically discover the network topology and keeps it up to date as the VMs move around in your virtual infrastructure. The second thing is flexible networking and service chaining, right? With the advent of 5G, what telcos want to do is to be able to offer new and agile services, right? When I say agile services, this essentially could leverage multiple components, and these components are going to be connected through what is called as a service chain. But these service chains in the physical world, it used to be static, right? You used to know, you can very well clearly stipulate in the network that, okay, your EPC is going to be connected to this particular DPI, which will then again be connected to maybe a video optimizer and so forth. So it used to be very statically linked service chain. But in the upcoming era of 5G, this is going to be constantly moving, right? Constantly changing. So again, how do you keep track of all these variations and changes in the network? That's another big challenge. The third element is capacity planning and forecasting, right? Again, with this dynamism in the network, this becomes a very critical element and pretty complicated function. And the fourth one is, it's in fact the most difficult thing in the virtual plane, which is the issue isolation aspect, right? I mean, I have another slide where we will double click into it, but just to introduce the topic, there are multiple tiers involved when you're delivering a virtual function, right? You have the virtual infrastructure layer, which is your compute, storage, and networking. And then you have your, you have the orchestration layer, then the application services tier, and there are multiple tiers in between too. So when you have a problem, let's say a customer calls into your call center and says, hey, I'm not getting the 100 Mbps service that I signed up for, then how do you isolate the problem? How do you figure out where exactly this issue, where exactly the problem is manifesting? It becomes extremely complicated in a virtual environment. So you need to have specialized tool and specialized automation capabilities in order to specifically pinpoint the location of the problem, right? So that's another key thing that we should not lose sight of. The last one is closed loop automation. I mean, as I said, in a dynamic environment, trying to do everything manually or even through a UI, it's going to be very, very cumbersome and very difficult. You can do some elements like service creation and service retirement. That's something that you can do. But automated management of things, I mean, that's very, very difficult to do. So you need to have a closed loop automation system which can constantly keep track of the health of your network, health of your services, health of your individual components, and take appropriate corrective actions as and when it is required. Right? So these are some of the key challenges that are, I mean, they are either new in the virtual world, or they are kind of enhanced or emphasized in the virtual environment. So this is a double click on the issue isolation piece per se, right? So on the left side you have the various tiers. So you have the transport tier, the infrastructure tier, virtualization tier, and so forth. And each of these tiers deliver some specific functions. Now, not all of these functions are going to be exercised for every single use case that is depicted on the right. So you could have, for example, in the case of a network operations use case, like a network operations person, if he's trying to diagnose a network outage, for example, he's not necessarily bothered that much about capacity as long as the utilization levels are not above the threshold, right? But he is more worried about, okay, what are all the alarms? What are all the individual CPU utilization levels and things like that at a more finer granularity level? That's what he is going to be interested in. Whereas if you contrast this with a network planning individual, he is not bothered about these metrics. Right? He is not bothered about alarms and things like that, but what he is bothered about is at a gross level or at an aggregate level, what are the trend lines indicating? How is the growth? What is my resource utilization or resource consumption levels at these individual tiers? I mean, and even within these individual tiers, what is my resource utilization across these various functions that we are talking about here? Right? That's what he is going to be interested in. So now let's try to look at how would a network operations person or a network planning person try to diagnose or derive an insight from this particular setup, right? So first of all, he needs to collect information across all these tiers, because no single tier is going to give the answer to his question. He needs to collect information across all these tiers. That's number one. And number two, he has to now start correlating all these things, right? You cannot just take one set and say, okay, this is my information. No, you need to be able to correlate it across all these tiers and then derive the meaningful insight out of it. For example, let's take a classic example of a customer care scenario. I mean, the use case that I talked about earlier, right? So a customer calls the telco call center and he says, hey, my 5 Mbps service is not working. Now, what would the call center guy is supposed to do? All he knows is this particular customer A, has subscribed to a 5 Mbps service, which is not working. That's all he knows. But now he needs to double click and figure out where exactly the problem is. So in other words, there has to be service awareness. This particular service awareness needs to be created all through the stack. And then he needs to be able to start from the services tier and double click and drill down into each of these tiers and identify the specific component where there is an issue. So that calls for a significant operational analysis. I mean, there is a lot of intelligence that needs to go into this, behind this particular piece. So this is something that is really huge when you talk about the telcos of the next generation. Another problem is we talk about service agility, service flexibility, and service reliability, right? And this just gets emphasized when we talk about 5G networks. Now, in the past, if you just roll down the clock a little bit, in the past when telcos upgraded from 2G to 3G to 4G, there was always a stated goal that the networks have to be backward compatible, right? So because of that stated goal, what the telcos have always been doing is they used to make incremental modifications on top of their existing infrastructure. I mean, there were significant changes in terms of the APIs and technology and stuff like that, but the point is you don't necessarily bring in any radical modifications. It was always an evolution, not a radical change, right? Now, what this resulted in is extremely rigid cores, because you need to have you need to have a defined environment. You need to put some kind of a fence around your architecture, which then will allow you to evolve as the various radio generations evolve, right? So you need to have, this resulted in a rigid core. And because of the rigid core, you had this problem of monolithic services, right? And NetOps also become kind of siloed. So this is an issue that we are faced with today. But with 5G, and particularly when we talk about network slicing and use cases like that, you can no longer afford to operate in this particular way, right? We have to completely change the way we look at things. So let's look at how we would realize a service. I mean, typically how a service is realized in a 5G environment. Now again, what I've shown here is multiple clouds. You have a mobile edge cloud, a mobile core cloud, IMS core, and as well as the IT corporate public cloud. Now, and in 5G, we have this concept of network slicing, where you can create an individual, basically you're essentially taking your entire network and then partitioning it into individual slices. And you're dedicating each of these slices to a specific use case or to a specific customer, right? So in this case, I'm essentially showcasing 3 different slices. One is a connected car service, the second is a VoLTE service, and the third is a broadband service. But remember, all the services are running on the same network, but each of them are operating as a secure multi-tenant. In other words, whatever happens in that slice stays within that slice. No other slices are impacted because of something happening in this particular network slice. So there is a very strong isolation between the various slices, right? So in this model, now when you're talking about instantiating all these applications like a virtual EPC application or a IMS application, now they could be instantiated either in a VM form factor or in a container form factor, because that's another important thing we need to be cognizant of, right? So there are alternatives available in the way you can realize your service. So, and going back to the previous slide, so what we are trying to do is to have a unified cloud orchestration and automation capability clubbed with integrated operational intelligence across all these components, both the VM world as well as the container world, across all these network slices. Right? So imagine, I mean, just think about the complexity of the problem here. So what we really need to do is to provide this on this particular environment. So what VMware has brought to the market is a vCloud NFE solution, which is essentially a tailored solution which is comprised of our SDDC platform, which is the vSphere compute hypervisor, the vSAN storage hypervisor, and the NSX network hypervisor, clubbed with our VMware integrated Openstack, which is our Vim. And then in addition to this, we also added another component, which is something very unique to us, because we feel that if we want to address all these operational challenges that I just talked about in the previous slides, we need to have some dedicated solutions that not only enables people to instantiate virtual functions, but it is also able to operate and manage these functions on an ongoing basis, right, and delivers this 5 levels or 5 nines of reliability and so forth. So we introduced this concept of NFEI operations suite, which is comprised of 3 major products. One is vRealize operations, which tracks the health of your complete virtual infrastructure, and it allows you to diagnose a problem if something goes wrong. And in some cases, it also enables you to fix those issues, right? Once you identify the issue, it also has some capabilities to fix those issues. And the second product that is part of the suite is the Log Insight, which is a log aggregator and correlator. So it is capable of taking in log information, events information, alerts, and so forth, not only across the VMware stack, but also third-party stack, so that now you have a single entity where you can process all the alerts and stats that is coming out of the system, and then cross-correlate it across the various tiers. The third one is Network Insight, which provides you a 360-degree visibility into your entire virtual network topology. Because as I said before, in the virtual world, the network topology is extremely dynamic. So one single person cannot really track what's happening in your network. So you need an automated way to do it. And that's what this Network Insight tool provides you. It constantly tracks your topology, and it also has a time graph capability, so you can go back in time. Like you can go back to Sunday early morning 3 a.m. and figure out what was the status of the network when that outage happened, right? So it has that time graph function as well. So building on top of this infrastructure, we also have integrations into the Mano layer. So we do partner with several orchestration vendors to provide that level of capability. And then the third element is ready for Nfe Program. This is something very unique for VMware. So where basically, as a telco, if you want to get the confidence that a specific VNF will run predictably and satisfactorily on a platform, then you will look for some sort of certification. And that's what this one is essentially. So here, VMware as a company, we basically reach out to the various VNF vendors, and we bring on their VNFs onto our platform, and we certify those VNFs to run reliably on our platform. Right? So that you as a telco, when you consume it, you are confident that yes, this VNF will run safely on my infrastructure. The last one is our involvement in the orchestration and particularly the standards organization. So we do participate in ONAP and OSM. We are a platinum member in both these organizations. Actually, I have a couple of slides on this later on where I will dive deep into explaining what are we really doing in those two organizations, and particularly in the operations management space. And this is the last one. And the last one is the Lighthouse solution development. Like, infrastructure is one thing, right? But then how do you really design and deploy an infrastructure for a specific use case? Now that is something extremely key, right? So that's what we try to do using this Lighthouse solutions, where we provide reference designs for deployment of reference designs for the deployment of the infrastructure, vCloud NFV infrastructure for these specific use cases. And we are just growing this list as it becomes, as days roll by. Okay, now a little bit about the VMware integrated OpenStack. And the previous speaker, he talked a lot more about this, and the next speaker is going to double click more into this particular topic, but I just wanted to give you a very, very high level introduction. VMware integrated OpenStack is a full DevCore compliant OpenStack distribution. For the people who are not aware of it, DevCore compliancy means that all OpenStack APIs, all standard OpenStack APIs, will behave the same way in our distribution as it was in the original upstream distribution. That's really what DevCore compliancy means. And in fact, when the latest compliancy standards was announced a couple of months ago, VMware integrated OpenStack and one other vendor were the only ones who were certified within a month of its announcement. So we are very, very particular about this, and we are always in the ahead of the curve when it comes to certifying ourselves to the standards. The bottom of this layer is essentially the VMware SDDC. That's what is our virtual infrastructure layer. And there are two additional components that we package along with our OpenStack distribution. One is the VIO management server, which is a tool that plugs into our vCenter console, and it helps us to manage the OpenStack install itself. So that's the component which handles your patch updates and upgrades and so forth. In fact, one of the key value propositions of VIO is hitless and seamless upgrade. Now, what I mean by that is when you upgrade your OpenStack from version 3 to version 4, right? the workloads that are running on your virtual infrastructure are completely unaffected. They don't move, they are not powered off or anything. You are just updating or upgrading the Openstack install alone. Right? So that hitless upgrade is extremely key, because many carriers that I have spoken to, they are still running extremely age-old OpenStack version, and the primary reason is because of this upgrade issue. They are extremely risk averse, and they don't want to touch a running system because they don't know how it will function. Whereas in our case, we have this blue-green upgrade approach, where we basically say we not only provide hitless from a workload standpoint, but we also ensure that if you want to upgrade and then test it and it is not working fine, then we give you an opportunity to roll back to your current running instance. And then the second unique element is the OpenStack private extension. Now, this is essentially a component which exposes some of the vSphere unique capabilities, right? Which are not necessarily available in the other hypervisors. So this is essentially what that particular component is. But having said that, we are not trying to keep this as a proprietary element. We are constantly in conversations with like-minded vendors and operators to see how we can upstream all these private extensions to the OpenStack community, so that it gets a more wider following and all of us can benefit at the same time. So we are in constant conversations. So if you're interested, connect with me later on, and I'll be more than happy to discuss them. Okay. So now we announced VIO 4.0. This is our latest release. This was announced in VMworld in September. So as is indicated over here, there are so the VIO 4.0 has two major kind of capabilities. One is the common capabilities, which are available for both which is applicable for both the enterprise and the telco scenarios. Like, it's based on Okata for starters. And then it has some scalability capabilities and logging and analytics, which I talked about earlier. And as the previous speaker outlined, it also comes with an integrated container, Kubernetes-based container support, right? But in addition to it, we have some key telco features. The first one that I would like to highlight is a secure multi-tenancy. Now, if you remember in the earlier slide, I was double-clicking on a specific aspect of providing resource guarantees and resource isolation. That's what this capability provides. Because today, if you look in the OpenStack implementation, OpenStack, there is no specific resource guarantee. Like, you can set a quota for the individual projects. The quota only defines what is the maximum amount of resource you can consume. But it doesn't guarantee that the resources are going to be available when you want to consume them, right? So that is a problem for telcos, because they want resource guarantee. The second aspect is resource isolation. You don't want an EPC application grabbing all the network bandwidth such that the IMS application is left with no bandwidth, because then your 911 calls cannot go through. So you need to provide some level of isolation between these applications or these tenants. So what we provide here is essentially these two capabilities. A resource guarantee, in which case you can set a quota for a EPC application to be, let's say, 1,000 CPUs, but you can say, okay, I want to guarantee 500 CPUs of it. So definitely it will get 500 CPUs at any point in time, right? But it can grow up to 1,000. Similarly, we also provide resource isolation. So the network bandwidth that is consumed by your EPC application will never will never grow and eat into the virtual IMS bandwidth. So that's the secure multi-tenancy. In addition to it, we support EPA, the full Intel EPA functions like CPU pinning and hyperthreading, NUMA placements, and all those elements. And then dynamic scaling as well. Scaling both in terms of scale-out architecture as well as a scale-up architecture. So we support all these capabilities. So that's a brief introduction about VIO. So now let's see how the vCloud NFV solution actually delivers this operational management capability that I talked about earlier, right? So we have this capability called NFV Operations Intelligence, and the prime function of that is to be able to provide information like FM, PM, and CM kind of information to the consumers, right? The consumers could be either your OSS BSS system, or it could be a big database system, or it could be a service assurance application. whatever be the application. So you need an ability to collate all this information from your underlying infrastructure, correlate that information, derive some meaningful insights, and pass these insights to the upper layer so that the upper layer can take appropriate actions, right? Either notifying the operations manager or taking corrective actions. Either way, you need to be able to supply this information. So that's what this Nfe OI component does. So two key things that it needs to have in order to deliver this promise is A, it has to be service aware, right? It can no longer just operate in the dimension of compute and network and storage. It needs to be able to step up the ladder and start looking at it from a service standpoint. Is it a EVPN service? Is it a EPC service? Is it a CPE service or a SD-WAN service? It needs to be able to look at this information under that context. So that's the service awareness capability. The second element is the transport, right? So you need to also be aware of what is the underlying transport. So because you need to club the service awareness with the underlying transport in order to perform some specific use cases. The other element is many of the telcos have already implemented these kind of metrics gathering telemetry applications, and they may have their own data lakes, or they may have their own databases like metric databases. So you don't want to live in an isolated world, right? So you want to be able to take all this meaningful information that is available across the network and then apply your operations task on top of it. So that's another key element. So either Nfe OI can pass the information to those data lakes, or it has an ability to consume the information from these third-party sources and then do meaningful analysis and derive insights and then pass it up the stack. So it has both the capabilities. Now, whichever way the telco wants to go, we would be able to support it, right? And the final element is, okay, you need to have a closed-loop mechanism with your Nfe orchestrator or the orchestration layer, right? And there are some standards that are being built right now as we speak under the HC community, and we are participating in these standards body in order to ensure that the relevant use cases are implemented appropriately. Okay, so now let's look at the strategy, right? Like we talked about the philosophy, so now let's look at the implementation, how it actually looks like. So one thing is, I mean, you have multiple clouds, the mobile edge cloud, mobile core cloud, and there could be multiple VNFs spread across these two clouds. But many a times the telcos may have their own what should I say, operations intelligence agents which are deployed or strewn across the network, which is collecting insights, right? So these agents, the VTA is nothing but virtual traffic agent, that's what it really stands for. So these traffic agents could either be running in your private cloud or on the network itself, like it could be a simple tap on your router, for example, or it could be running on your device as well. In some cases, even the devices are collecting metrics from a telemetry standpoint, right? And there are several solutions, like Netrons is one of the key examples, right? They have this kind of a capability today. So what we need is the ability to integrate our vCloud Nfe operations intelligent element, because we have complete information on the virtual environment, along with this third-party solution, which is deriving metrics on the network level, at a packet level, right? So now so things may be working extremely fine in the virtual world, but once it crosses the virtual world and goes into the physical world, it could experience some problems. So how would you detect where the issue is? So you need to be able to collect information from both the worlds and then look at the correlated information. So that's what we are talking about here. Some other customers, what they also do is they go at the next level and start deploying specific packet analyzer, like DPI kind of packet analyzer, to not only look at it from a packet standpoint, but also look at it from the content of the packet standpoint, right? So that's another way you can essentially do this. So in essence, the idea is once you have this infrastructure and once you have your virtual functions instantiated either in the VM world or the container world, you need to have a unified cross-tier operations management capability that delivers these four elements: operations planning, log correlation and log insights, network insights, and metrics information. So that's really what we need in a cross-cloud sense. From a product standpoint, so the VMware integrated OpenStack is the layer which essentially sits on top of this underlying infrastructure, but then we leverage the standard templating technology, be it Heat or Tosca or Gang models. I mean, we support all these elements, so you can use these templating mechanisms to instantiate and manage your services. But in addition to it, we also interface with the various orchestration entities, like the pure play orchestration vendors like the Cloudify, the Rift.ios of the world, or the standard service orchestration frameworks like your ONAP and OSM frameworks. Okay, so very quickly, I know I'm almost there. Very quickly, so as I said before, we are involved. We are one of the platinum members in ONAP. So as part of ONAP, we are essentially leading two major efforts. One is in ensuring that this service orchestration framework is compatible not only with the plain OpenStack, but it also caters to a cross-cloud scenario, right? Because in some cases, you want to leverage the same service orchestration framework against the VMware stack, or be it Azure stack, or be it a AWS stack. You need to be able to leverage the same service orchestration framework. So that's one initiative that we are leading. The other initiative is the overall operations management capability is going to be only as effective as your underlying data models. Because if your data models are very, very proprietary, then it becomes very difficult for you to stitch solutions together, right? So in order to ensure that the telcos don't get themselves locked into a single vendor proposition, we are working with our other vendors in the community, in the ONAP community, to define model-driven abstractions for all the operational elements. So we are defining Tosca-based models and other models in order to ensure that we have cross-vendor interoperability for all these for all the functions that I just talked about. On the OSM front, we are again a platinum member in OSM, so we have integrated our VMware integrated OpenStack into the OSM framework, and this is again, it's already available and it is published in the OSM website. I believe that was my last slide, and if there are any questions at this time, I would like to take them. Okay, thank you. Thanks a lot.